Evaluate the integral using the substitution method. The use substitution method works best if we have an expression that is being raised to a power. For the first integral, we see that x is being raised to the power of 2, and 1 plus x cubed is being raised to the power of 1.4. 1 plus x cubed is a more complicated expression than x, and so we will attempt to let u be 1 plus x cubed. Let u only be the expression that is being raised to a power. Then the differential du, or the derivative of u with respect to x, is 3x squared. Don't forget dx. And then we isolate dx. To get dx by itself, we will divide it by 3x squared. So dx is du over 3x squared. We will replace dx with du over 3x squared, and we will also replace 1 plus x cubed with u. And so we rewrite the given integral as the integral. There's nothing for x squared yet, so we will rewrite x squared over. In the denominator, 1 plus x cubed is now u, being raised to 1.4 power. And then dx is du over 3x squared. And we see that we can cancel out the x squared top and bottom. This will give us the integral of 1 over u to the 1.4 du. But we rewrite this as the integral of u to the negative 1.4 du. There is a number 3 in the denominator, so we will write 1/3 in front of the integral sign. Don't forget this 3 in the denominator. 1/3 is a constant multiple, so we would rewrite this. U to the negative 1.4 is a power, and so we would use the power rule. Negative 1.4 add 1 is negative 0.4, and we divide by the new power, negative 0.4, plus c. Simplifying this, we see that this is 1 over 3 times negative 0.4 is negative 1.2 in the denominator. U to the negative 0.4, but u is 1 plus x cubed, raised to the power negative 0.4 plus c. And this is the answer. There's no need to use the fraction in this case because in the given problem, we were given the decimal. But if we want the answer in terms of fraction, negative 1 over 1.2 is negative 5 over 6. 1 plus x cubed, rewrite it, and negative 0.4 is negative 2 over 5. This is an alternative answer. For the second part, we will let u be the expression in the power of the exponential e. U equals 1.2x minus 3. Then du equals 1.2 dx, and so dx equals du over 1.2. We will substitute dx with du over 1.2, and we also substitute 1.2x minus 3 with u. And so we rewrite the given integral as 3.2 minus 4e raised to the u power, and then dx is now du over 1.2. Over 1.2 is the same as saying 1 over 1.2, which is a constant multiple, so we would rewrite it in the front of the integral. 3.2 is a constant, not a constant multiple, so we would rewrite this inside the integral, minus 4e to the u power du. To evaluate this integral in terms of u, we would rewrite the constant multiple 1 over 1.2. The antiderivative of 3.2 with respect to u is 3.2u. Minus 4 is a constant multiple, and the antiderivative of e to the u with respect to u is e to the u plus c. And then we distribute 1 over 1.2 to everything inside the bracket. 1 over 1.2 times 3.2 is 8 over 3 using the fraction, minus 1 over 1.2 times negative 4 is negative 10 over 3, and then e to the u plus c. The last thing we will do is to substitute u with 1.2x minus 3 to get the final answer. So the answer is 8 over 3 times 1.2x minus 3 minus 10 over 3e raised to the power 1.2x minus 3 plus c.